Hello everyone. Today I'm going to talk about the books and works of Benoit Mandelbrot, specifically this book here, The Misbehavior of Markets. Just to start, I'd like to explain that that's not my personal or professional opinion. I'm purely analyzing what he says, not even analyzing, describing in a compressed way what he says. And this book is very interesting, his work is very interesting, because he generates a new perception and a new field, a new way to analyze the financial market and financial assets and financial things in general. So who is Benoit Mandelbrot? So Mandelbrot is a mathematician and physician who worked for over 35 years for IBM, in which they paid him for developing anything that he wanted. It was purely scientific. Like, he had the freedom, he had the intellectual freedom to develop things that he believed in. And he was also a professor in Yale and Harvard. And he is a very interesting person, because today we know Nassim Taleb, Nicholas Nassim Taleb, who is the creator of The Skin in the Game, The Black Swan, Fooled by Randomness, the statistical consequences of fat tails, and his work is in a big training. And one of the people that Nassim Taleb based most were in Mandelbrot. So Mandelbrot started analyzing the industrial averages of the Dow Jones and also the price of cotton. And then he saw that it doesn't apply for the normal distribution and for the standard method. So the normal distribution and the standard method, they use the bell curve, that it's like a bell, and there is the center, the mean, and we have things from the mean, like distance from the mean, but based on standard deviation. And the further it goes from the mean, the less likely it is to happen. He realized that the tails that should happen very, very rarely, they happen way more often than it should. And he analyzes that, okay, bell curve could be used for IQ, for height, for things that are already, that there is a constraint created by nature. Like, in finance, it doesn't work. It doesn't work like that. And then he realizes that, for example, in 1987, we have that big crisis where the stock fell 32%. And the probability of that to happen based on the standard method was 1 in 10 to the power of 50, which is, it's basically, it should happen once in the history, or even less than that. And that happened. And another thing, some years later, in 1990, you had another crash, and the probability was 1 in some millions. And then in 1997, we had a recession in Japan. China was signaling some weakness, Russia was running out of cash, and the impeachment of Bill Clinton started to run in US, and we had some four drops in the same month, that the probability that to happen was 1 in 10 billion. So, and actually in 2001 we had another, in 2008 we had another. So he saw that things that should be impossible, they happen way more often, like the black swans exist. And in the way we calculate using those methods, and actually it's interesting because in the Black-Scholes method, Norton method formula, we use the normal distribution, and for most of the many famous financial metrics, it's common to use normal distribution. And then he says, okay, so what could be better? What can we do? What could replicate better the behaviors? And then he started analyzing, and then he says, wait, one of the things that the standard methods uses and uses as an assumption is that, for example, each new change, every day we have a change in the stock. Every day there is a change. So every change should be independent. And he says, no, it's not independent, because when we have turbulent times, we can see like the volatility of the market getting higher, and then we have calmer times, it gets lower. So he says, he started analyzing the behavior of the wind, and he said, no, actually financial markets, they behave way more like the wind. And then he say, okay, interesting. And he realizes that there is very calm times, the mild times with a little some wind, and then in the hurricanes, the wind is super high and super crazy. And then he say, okay, in the standard distribution and in the standard method, we just consider the mild wind, but actually the wind could be even calmer or even crazier. And so our those methods are not prepared for that, and according to him. So then he says, okay, so let's develop something different. And what he says is like, okay, actually, because the chains are not independent and because they vary, what can we use for replicating some physical phenomena? And one example is the wind, or like hydro. And then he realizes that using the fractals, the multifractal methods, we could develop things more prepared and more likely the real behavior of the markets. Because using that, we can predict some spikes and some crazy times and super lower times. And using the standard methods, we have like this Brownian motion, which is just like this. And they say, no, that's wrong, and we should be using a multifractal model. How to use it, I'm going to discuss. But first, it's going to be in another video, because I have to go into some stochastic ideas and assumptions, and it will take a little bit more time. I will indicate for you that if you're already curious, some works. First of all, is the work of Fan Yen and Jun Wan, Statistical Properties and Multifractal Behaviors of Market Returns by Ising Dynamic System. Ising Dynamic System is a physics method, and it's used more for aerodynamical analysis. Another one, Forecasting Crude Oil Market Volatility, a Markov Switching Multifractal Volatility Approach. This is young. The first one was from 2012, this is from 2016. We also have, just go to Google Scholar and type multifractal models finance, and then you see some. There is no many, and the ones that we have are after 2012, so they're pretty new, most of them actually. So if you're a PhD, this is something interesting to study. He doesn't have anything ready. He says that he doesn't have anything ready to replace anything that we have now, but he has an assumption and an idea. In some cases, they're replicating, they're getting good results. So if you just listen to this video, I invite you to start studying it. Maybe you can bring something interesting from these studies. It could be something useful for the future of finance. So thank you very much. And just to repeat, it's just an analysis of what he says. I'm not implying any personal judgment. Thank you.